My lesson video on electricity equations covered a lot, and really it covered a lot of mathematical formulas. What we're going to do now is we're going to go through the theory, and the best place to start with that is current. Let's start with the defining equation. Current equals charge divided by time. I equals Q over T, which in units is amps equals coulombs over seconds. 1 amp is 1 coulomb divided by 1 second. So, current is the rate of flow of charge around the circuit, or in better words, current is the amount of charge passing a point per unit time. This could be happening in liquids, like in electrolysis in chemistry, but in physics we'll almost always be talking about current moving around a circuit. Rather unfortunately, the equations and maths and everything for electricity was worked out before we really knew what was going on, so all the maths and circuit diagrams are based on positive charge, with conventional current being the flow of positive charge around a circuit. That means that if I draw a basic circuit like this, with a cell, wires, a resistor, and more wires, and label the cell correctly with the long side being positive and the short side negative, the theory and conventional current flows from the positive side of the power supply to the negative side, this way round. In reality, the charge is carried by electrons, the flow of free electrons in a metal conductor, from the negative side to the positive. So, we have conventional current going one way and electron flow going the other. That is really annoying, but we're stuck with it. Now we have a current in a circuit, we probably want to measure it. Since we are measuring the amount of charge flowing through the circuit per unit time, we're measuring the current in the wires. So we need to put our ammeter right inside the circuit, so it goes here. The electrons carry the charge from the cell, through the wire, through the ammeter, through the resistor, and back to the cell. The ammeter can measure the current in the circuit by being placed in series in the circuit. What if we added another ammeter here, further from the start of the circuit? How will the current be affected? Well, think it through logically. Think it through. Trying to go with your intuition, with the first idea that pops into your head, rarely works with electricity, unfortunately. Start with the definition. That current is the amount of charge passing a point per unit time. If we say that we have 10 coulombs leaving the cell every second, then we will have 10 coulombs passing this ammeter every second, and 10 coulombs passing the resistor every second, and 10 coulombs passing the other ammeter every second, and 10 coulombs reaching the cell every second. There was nowhere else for the charge to go, so it just flows around this circuit, staying constant. Current is the same everywhere in a series circuit. In summary then, in a series circuit where everything is connected in a single line, the current is equal in all parts of the circuit. What if we add a parallel branch to the circuit, making it a parallel circuit? Well, the electrons will carry charge to this point, but now have a decision to make. Yes, I know I said electrons are making a decision. They have to decide which branch to take. The two branches are identical, so half will go this way and half will go this way. Let's put in a couple of ammeters to compare the two branches here and here. And so let's think the current through. If we again say that we have 10 coulombs leaving the cell every second, then we will have 10 coulombs passing this ammeter every second, and then at the junction, half will go this way and half the other. So we will only have 5 coulombs passing this ammeter every second, and 5 passing the resistor too. And 5 passing this ammeter every second, and the same 5 passing this other resistor. At the other junction, the current combines again, so we get 10 coulombs passing this final ammeter, and 10 coulombs reaching the cell. In summary then, we already know about series circuits, and in a parallel circuit, the current leaving a cell is equal to the sum of the currents in each of the branches. And conventional current flows from positive to negative, whilst electron flow goes from negative to positive.